Take a network break. I'm Jonna Johnson.
I'm John Burke.
Grab a virtual donut and let's run through the week's announcements. We'll be hearing about an acquisition by Palo Alto, another hiccup from our friends at Cloudflare, some AI announcements by Itential and Gluware, and more. But first, a quick note from Itential, who is sponsoring this episode.
Build network automation tools and share them with your entire network operations team safely and reliably. You can do this with Itential. Visit Itential.com to find out more. That's Itential.com.
Also, stay tuned after the news for a sponsored Tech Bytes podcast with IBM Sev1. Sev1 is a network observability tool that gets to the root of performance problems by focusing on all the layers that an application operates at. We speak with IBM Sev1 CTO Brandon Hale about the product's architecture, how it works, and what problems it can help you solve. Pretty cool, so stay tuned.
And moving on to the red alert for this week, let's keep our eyes on a 0 day that's been announced this week. There were a total of 768 CVEs created in the past week, the week ending November 20th, and another 2,602 that got updated. 314 of the CVEs scored a critical rating, which is a CVSS score of 9 or higher, and 47 scored 10 out of 10. This week's red alert did not quite hit the 10 out of 10, but it scored a 9.8. It is CVE 2025-64446. It is a relative path traversal bug in Fortinet's FortiWeb product. By working sideways through a file tree via sanctioned commands sent via HTTP or HTTPS, a remote attacker can execute admin commands on the system, including adding, changing, or deactivating firewall rules. This vulnerability is being exploited in the wild already. The workaround is to either make the interface unreachable by HTTP and HTTPS, or to roll out the updated version of the software and thereby get the patch that fixes this bug. Now, the weird thing about this, weird to me, is that the affected versions of the operating system are all the even-numbered releases in the version 7 train, 7.0, 7.2, 7.4, and 7.6, and version 8 also is vulnerable. At least prior to the new version, which is 8.02 and contains the fix.
So, John, what about version 7.8? Is there not one?
I don't think there was one. It wasn't listed as being unaffected, so I'm assuming it didn't exist.
Okay.
And also this week, Fortinet also announced a second 0 day on FortiWeb. This is CVE 2025-58034, which only scored a 6.7 out of 10, but is already also being exploited in the wild, sometimes in chained attacks, leveraging the red alert flaw as well. It has the same affected versions, the same workaround, and the same fix. Get it up to date. All the CVEs are linked in the show notes.
Great. Thanks, John. And moving right along to a big piece of news this week, Palo Alto Networks is acquiring Chronosphere. On November 19th, during its earnings call, Palo Alto Networks announced a bunch of things, which we'll get to, but key among them was that it has entered into a definitive agreement to acquire Chronosphere. For those who aren't aware, Chronosphere is an observability platform built specifically to address the needs of massive AI clusters. Palo Alto is saying it intends to integrate the acquired monitoring platform with its own recently released Agentic's AI agent platform to create what it calls an autonomous remediation platform, which is able to use the petabytes of monitoring data harvested to detect performance problems, find their root causes, and automatically remediate the problems, thus dramatically lowering any median total time to contain these problems, which is our preferred metric. Palo Alto will be spending $3.35 billion in a mix of cash and replacement equities and expects the deal to close in the second half of 2026. For context, Chronosphere has an annual recurring revenue of about $166 million, having more than doubled year over year. So this is looking like a very good strategic acquisition for Palo Alto. John, do you have thoughts?
I agree that it's strategic for them in the combination with Agentics. I don't know that it had to be Chronosphere that they acquired, but acquiring somebody in that space makes a lot of sense for them at this time to help them gain new and more compelling relevance to the AI ecosystems that are spinning up out there?
Yeah, I think I agree with you. I think it's a good move. Obviously they're clearly acquiring resources, talent, and functionality, and it definitely fits in with their overall strategy. So not much to say that's negative. I think the only thing that I would question is why it's going to take so long to close a deal that is relatively straightforward. It seems like 6 months is 6 to 7 months seems like an extended period of time, but they may just be wanting to do their due diligence and take their time. Who knows?
It's also good not to try and make too many predictions about how the antitrust machinery will deal with this if it rises to that level.
Excellent point. Predictions are hard, particularly about the future, as Yogi Berra said. So, yes, wise move there. If Palo Alto Networks closes early, they will simply look good, and being a little more conservative in the time frame makes plenty of sense.
It is story time with Ethan, courtesy of today's sponsor, Itential. For several years in the pre-automation days, I was on an engineering and architecture team that would help develop standardized code stanzas for new features that we would bake into our managed router offering. Now, once that configuration code was fully tested, we would move into deploying the code to client routers. By hand, often with a network operating system code upgrade required first. And as you can imagine, every so often something would go sideways in the process. The ops tech would fat finger something, a paste buffer would fail over the WAN because reasons. Something, usually a human something, would go wrong. My point is this, back at that time, there was no way to craft an automated process that would make sure the config went in exactly right every time and then share that process with the ops team. They would just punch the chains into the CLI like a savage, and often they weren't even knowledgeable enough to react correctly when something went wrong. Time has thankfully moved on. Now we have infrastructure as code, and we've got developer tools and programmatic logic that we can use to code a mature playbook or a script that's got input checking and error handling and testing. And what's more, we can share these tools with our ops team without them having to understand a thing about the tool's inner workings or even have an environment to run the tool in. Now, how does all of this happen? With Itential. Itential can create an automation execution environment everyone in networking can use safely and reliably. To find out more about Itential's products and how they help you build an automation platform, visit Itential.com. You can test drive Itential free for 30 days. That's Itential.com.
And continuing our news, Cloudflare managed to self-own again. At 11:20 UTC on November 18th, internet users trying to reach sites front-ended by Cloudflare began to get error pages instead of the websites they were going after as Cloudflare, quote, began experiencing significant failures to deliver core network traffic, end quote. Cloudflare would like to emphasize that this issue was not caused either directly or indirectly by any form of cyber attack or malicious activity. It wishes to emphasize that because its first pass at explaining the outage was to blame on a hyperscale DDoS attack, but further investigation revealed that the real root cause was database management. Why am I not surprised? It's always the database in the end.
No. It's usually DNS. Come on.
That's true. Yes, there's that T-shirt floating around. Anyhow, CEO Matthew Sweet's blog entry on the incident reports that a change to a database system's permission made the database spit vastly more data than was expected into a feature file that feeds their bot management system. The routing nodes were then hit with a feature file twice as large as the previous one, but couldn't handle it as it exceeded the maximum file size allowed. So the nodes failed. Sometimes they then recovered because the permissions change that drove the bloated feature file didn't get pushed to all the database nodes. So every 5 minutes, when a new version was generated, it might be correct or it might be supersized. So services flapped up and down unpredictably as a result, as many of us can recall, actually, from that outage. Once they correctly identified the core issue, the Cloudflare engineers stopped the rule change and the bloated feature file from propagating further, reverted to an earlier version, and had core traffic flowing normally. This took them about 5 hours after the initial outage began, with links in the show notes. John, your thoughts?
First off, let me just say much respect to the Cloudflare folks for finding their way to that root cause and fixing it in that time frame after watching how Microsoft and Amazon wrestled with their, yes, DNS related problems in previous weeks. I'm impressed that this, I think, more obscure kind of a root cause was found as quickly and fixed as quickly as it was. That said, I also have thoughts on why was this feature file being pushed out into production broadly without first going to a smaller test tranche of devices, since that limit, that size limit, was built into the core code running on all those nodes. Pushing the new file to any of them should have caused them to crash and caused engineers to back the change out and look at what was going on and figure it out before they dropped their whole network.
Well, I think the issue, John, is that they weren't explicitly changing the feature file. They were changing the permissions. So the link that's fuzzy here is their explanation is a change to a database system's permissions made the database behave wrongly.
Right. It returned twice as many records as it was expected to.
Right. But I don't have a good sense for how often these permissions get changed in normal operations and whether it's even practical to have, a test run for every single change. That I couldn't tell you because they don't say what the permissions change are and it is or was and where it fits in the context of things. So in general, it's always the right thing to test any change before, by pushing it out. But if this is a change that gets made 700 times a day, that's not practical. And then the question is, why did this particular one go through?
The change on the database itself, which resulted in the file bloating, wasn't in itself it was incorrect. The rules change was returning doubled records, but none of those records was inaccurate. And if it had come in smaller, even having the doubled records wouldn't have been a problem. There would have been, 2 entries for this profile of bot.
Sure.
And it would have been no operational issue. It was only because it was so big that it was an operational issue, which the database folks wouldn't necessarily care about. But when there's a rule change at that end of the waterfall, shouldn't there be automatic testing
at each
step in the consumption of it? It should be fully automated. This shouldn't require staff time to do it. And yes, it should happen whenever there's a change that makes whenever there's a change that affects the key input, the results should be tested in the output. And even if it's 700 times a day, it should still go to a test bunch before it gets pushed out to everybody.
I'm going to push back a little bit because, again, it's a permission change. So there isn't a direct corollary between the permission change and spitting out tons of data that people would necessarily see. Now, if you're saying that every change should have automatic testing built in, yeah, I can't argue with that.
In a production system, yeah.
Look, I've made that argument to you actually many times, and had you pushed back, but I would also
learned my lesson.
I would also say, it's the connection between the permissions and the size of the file that perhaps is a little bit. It makes me question whether this was kind of one of as gee whiz as you're kind of making it out to be. But yes, net. Props to them for figuring it out so quickly. Maybe next time they will automate the testing and such things won't happen. One can only hope.
One can hope. And the introduction of AI and AI ops into these sorts of things is intended to help make these things more practical in an every change kind of a situation, which takes us to our next news item, which is Itential releasing Flow AI. Itential has announced a new platform for incorporating agentic AI operations into network automation. They're calling theirs Flow AI, and they say that it will bring, quote, deterministic orchestration and, quote, contract-driven execution and auditability to AI ops environments. Flow AI is intended to allow AI agents some flexibility in pushing a solution while also protecting the enterprise by enforcing policies and processes that are required to make changes the right way. It takes a tiered approach to doing this. Enterprises build flow agents using a platform built into Flow AI, and the agents are allowed to, quote, interpret intent, reason over operational context, and construct goal-oriented plans using natural language and the knowledge already in the Itential platform. Agents, though, are not allowed to actually do anything in the environment directly. The platform also incorporates a model context protocol gateway and server that facilitate integrations with other agents and platforms that speak MCP. However, agent action plans that affect changes in the network work via a separate tier, which is the existing Itential platform, which can then enforce all the organization's existing defined intents and policies and workflows, and thereby prevent AI agents from doing things the organization network forbids, acting on hallucinations that don't reflect the reality of the network, and so on. Now, Flow AI is currently available only as a private customer preview, with the general release timeline not yet announced.
Well, that makes a lot of sense because part of the goal, I'm sure, is to discover any remaining bugs, and nobody knows how long that will take until it has been tested. But I do find it kind of interesting that there seems to be an assumption here that I'm not sure is entirely accurate, which is, I get it that the humans build the flow agents then give us their plan. And then what we then do is allow the platform to actually execute the plan that is built by the flow agents. What I'm not seeing here, well, what I am seeing is that it is the platform's job to then compare the plan against the policies and to nix anything that isn't policy allowed. So I guess what they're doing is they're using their platform to be both the understander and the enforcer, which is kind of interesting.
Right. Yep. Guardrails as well as hands in the network. Yep.
Yeah. So it's I guess the thing to find out would be, to what degree does a human need to understand that plan, or is it just the case of the platform saying, nope, this plan does not pass the policy sniffs test, or yes, it does. It's kind of an interesting way to use non-AI automation, which I believe is the case in the platform. Kind of interesting.
Yeah, it is. And I think the fact that they specifically call out building, quote, goal-oriented plans using natural language, unquote, is a nod to making sure that the output of the agents is human understandable. So yeah, if the Itential platform says, nope, not going to do it, a human should be able to look at it and see why pretty quickly.
Yeah, that does sound like it's the case. It'll be interesting to hear what the results are. Check the link in the show notes. Meanwhile, not to be left behind, Itential's competitor Gluware is doing something very similar, trialing its Titan AI. Network management vendor Gluware has launched its own AI functionality, Titan, which it describes as an intent-based network automation platform that is tailored to doing, quote, verifiable AI operations, end quote, in typical enterprise networks, that is multi-vendor, multi-platform, multi-domain. Gluware says Titan is built around a technology it calls the Device Interaction Automation Layer, DIAL, and a dial-powered validation engine. It incorporates a model context protocol, MCP server, for agent interactions, and ensures that every AI action driven through the MCP server is validated, auditable, and in accord with stated network intent. Gluware is also introducing MCP service integrations with Netbox and ServiceNow, two very good players in this space, for integration across network design, inventory, and service management function. Other main component of Titan is Copilot, which is Gluware's take on the Agentic AI network assistant. Copilot, which seems to me that's a very familiar name, but this one has a dash in it, so it's not the Microsoft one. Copilot admins build automation models faster, Gluware says in 99% less time, by providing contextual guidance, help with third-party APIs, and other assistance. Titan is in early field tests now, and Gluware expects to release it generally early in the new year. With show notes. John, thoughts?
I'm really intrigued by this one because from interviews that we've done with network administrators over the years, Gluware has done a very good job in the past of providing enormous leverage to them. It works in a declarative as opposed to a programmatic fashion. You define the end state you want and it gets you there. And yeah, it'll be very interesting to see how adding AI to that environment works out in practice, if it really is that good at helping folks build the automation chunks that they need to build. So
interesting. Yep. All right. Well, we'll be wrapping up today's episode with Palo Alto's earnings call. We sort of opened with them and we're wrapping with them. In the first fiscal 2026 quarter, Palo Alto reported that network revenue grew 16% year over year to $2.5 billion. Next generation security annual recurring revenue grew 29% year over year to $5.9 billion. And the remaining performance obligation grew 24% year over year to $15.5 billion. So basically, Palo Alto did pretty darn well in its first quarter of 2026 and is predicting to do pretty darn well in its second quarter, expecting security to grow to land somewhere between 6.11 and 6.14 billion for year over year growth rate of about 28%. Total revenue for the quarter in the range of 2.57 to 2.59 billion for a year-over-year growth of between 14 and 15%, and diluted non-GAAP net income per share in the range of 0.93 to 0.95, using 711 million to 715 million shares outstanding. So all good news from Palo Alto, which is continuing to make great efforts to be kind of the default platform in the security space. I know they've been thinking a lot about pretty much everything they need to be thinking about. There's an upcoming episode of Heavy Strategy that will talk about what some of the things they're doing in the quantum space. They're also looking at an AI browser. So they're really trying very hard to dominate this space, and it seems like they're succeeding. Any thoughts on that, John?
I honestly think that they are going to have a somewhat better second quarter than they're projecting. Just thinking back on the other kinds of security news that we've been reading out in weeks past, and the significant play that they're making for AI environments, enterprise AI environments specifically, I think they'll probably actually beat their own expectations a little bit.
And well, fortunately, we're not financial analysts, so take
Indeed.
that with a grain of salt. But we are more than happy for you to hold us to this prognostication and let us know in 3 months how we did. Meanwhile, that wraps it up for today. John, where can folks get more from you?
I'll be writing on Substack going forward, and mostly on nemurdes.substack.com.
Thanks. And you can find me there as well. In fact, if you go to our Substack, nemurdes.substack.com, there is a Contact Us tab that you can click to let us know your thoughts. Anything else? Any other comments for us directly? If you want to give us feedback on the show, as always, please write into packetpushers.net/follow-up. You can do that anonymously and just give us accolades, complaints, or just general thoughts. We love to hear from you. Finally, please do stick around for our sponsored Tech Bytes conversation with IBM Sev1. That's coming right up.
Welcome to Tech Bytes. Now, you know how a lot of network monitoring tools allow you to say, it's not the network. That's fine as far as that goes, but it doesn't change the fact that there is a problem that needs to be solved. So a more useful tool would not only tell you that it's not the network, but also what the problem actually is. That tool would be integrated up and down the stack so you know what's going on quickly and can move past troubleshooting and into resolution. Our guest is Brandon Hale, CTO at IBM Sev1. We're going to get an overview of the Sev1 network observability tool and explain how it helps get to the root of a performance problem by focusing on all the layers an application operates at. Brandon, welcome to Tech Bytes. Hey, man, give us the elevator pitch. I don't think you guys have been on our network before, so we haven't heard from you. Give us that elevator pitch of what Sev1 is and does.
Yeah, thanks for having us, and thanks for that great setup, because folks who have been in network engineering know when you're getting those trouble tickets, you're getting those frustrated users out at the branches and trying to use applications. They really don't care about line cards and packet drops and stuff like that, right? They're going to be like, when is Zoom going to be working again, dude? When can I use the back office applications again? Things have been slow. Things have been, I've been getting errors. So we really focus on what we call application aware network performance, because we know like the job that we're actually trying to do is deliver the app, not trying to deliver, routers and switches and things. That's the how. So we've done that across a couple pillars. What we see as the pillars of observability for your audience in particular is around the metrics that comes from the network devices, the flows that we can kind of observe applications running over those wires and over those devices, and then what we call synthetics or tests, which is like, hey, if a user wasn't actively using Zoom in Chicago right now, but that was a key part of my business. We just want to observe that all the time. We don't want to wait for a user to call us. We want to proactively, synthetically test that stuff. So that's how we view the three pillars of application aware network performance.
Okay, that's a helpful overview and provides some context. Can we get a little bit into the architecture? Like our audience is going to want to know, how am I getting this telemetry? Where is it going? How is it analyzed?
Yeah, sure. So like a really big, well, we have this joke website, guys. If you want to go to issnpdeadyet.com, that's the website that we run just for fun, and we really enjoy it. But we have had these conversations for years to be like, oh, it's going to be streaming telemetry, it's going to be Prometheus, it's going to be this, it's going to be that, and it's going to all change. But what we found to be the constant and something that works really well in all the environments we've ever been in is good old SNMP. So it's not dead yet, and that'll actually take you to our website eventually. But we do support all those other things, right? Like we're not stuck in the past. We're just saying like, hey, use what works, and if what works changes, like we've done things with Prometheus, we've done a lot of things with streaming telemetry, but SNMP is the best. And you used the word architecture, so I wanted to follow that up with a comment about why Sev1 is a little bit different from other products, because we're designed for the biggest environments in the world. Some of your biggest telecoms, some of your biggest investment banks. If you've traded stocks, you've booked airline tickets, flown on an airline, like all those networks are kind of the people who are using Sev1, and it's because of the ability to scale out the platform. A lot of systems, they might have a SQL database, maybe Microsoft, maybe Oracle, where all the data has to be kind of sent to. We have a peer-to-peer architecture where every server is adding additional capacity. It runs the web services, it runs the database, it runs the APIs. Everything is included in this unit of compute, if that makes sense. And you can keep scaling up and up your ability to run the platform without being a DBA or having to figure out how to build a bigger, SQL server.
So Sev1 is shipping me a box loaded with compute, and I'm pointing all of my telemetry, my SNMP, my flows to that?
Yeah, you could think about it as a box. We stopped shipping a physical box a while ago due to the move to virtualization and now containers. So people might be running on OpenShift, they might be running on VMware, things of that nature. But you could think about it as just another unit of compute joining the Sev1 cluster.
Okay. But that sits on my network, this unit of compute that I'm deploying in some
Yeah,
manner.
that's right. Yep.
Okay.
I like the way you said the move to virtualization, because it just happened yesterday. We're just getting our heads around it.
We're still catching up, but now Broadcom's really punishing us for the whole thing. We're really rethinking the decision, right?
So Brandon, back in the day, I used to run some APM tools, application performance monitoring, and the architecture there, or not the architecture, but the design of it to build it, you would have all these different features and functions of the network or of the application, different things you were monitoring, and then you'd build like this dependency tree and kind of create this stack so that the application performance monitoring tool could give you root cause analysis and these kind of things. Is that kind of the right mindset with Sev1?
We're trying to be helpful in that we don't want you to spend a lot of time setting things up, right? Like we want you to get right to the value and right to kind of answering those performance questions you have. So one thing we did in the past couple releases was to bring in a database of all SaaS applications. not literally all, but like thousands of them. And so instead of going and identifying these are applications on the internet that my customer uses, or sorry, my users within the company use, we've already pre-identified everything from Netflix to Zoom to Office to, ChatGPT. All that stuff is going to be automatically identified for you in Sev1. And we have a really cool blog post about this where we show it all kind of looked like soup before, right, Ethan? Like you'd see a bunch of IP addresses. If you want to look them up, they might belong to an Amazon, block. Be like, yeah, of course, everything Slack runs on Amazon and everything Microsoft runs on Azure, but like that doesn't tell me what the application is. So we've done all the fingerprinting and identification for you. Obviously, there's going to be some degree of your own applications, like homegrown. We can resolve those either by DNS, like they might have a DNS name, it'll automatically pick that up. And then our partner Instana, another IBM product, has a tremendous amount of depth in getting into the APM and actually tracing the applications and stitching together the different services that make up one macro service, micro into macro, if you will. But Sev1 is really trying to be the network lens primarily, or the majority of the time, we want to automatically identify what the apps on the network are.
So the different data you've gathered around flows, the things you know about SaaS applications, the fact that you've got that knowledge based on domain name metadata means that you can reflect back to me, not just here's a flow and here's some performance stuff, but here's the application that is indicated by this metadata, and the impact to the application based what we're seeing through the network performance lens is X.
Yeah, here's an example of why this has been really useful. I didn't have this feature, but when I was a network engineer, a common problem would be the users at a branch, right? They're all kind of competing for an amount of bandwidth, right? Like maybe they had an MPLS line, maybe they use the internet and some sort of SD-WAN type of solution over the top of that to try to make it more reliable. But you never really had enough bandwidth for everybody, right? So you'd start to apply QoS and you start to try to trade off like, okay, this application is going to be prioritized. But there's always contention for bandwidth, right? So when you come to Sev1 and say, hey, I see the alert that's telling me the interface on that router is all utilized, it's full. That's great, but like why? And so our capability to drill down on that says, hey, based on the flow data and my ability to identify and fingerprint all those applications, somebody's doing a lot of Netflix, dude. Or it could be anything. Like I've seen printers, I've seen print jobs going across the internet when they shouldn't be. I've seen all kinds of things, but just that ability to within a couple of clicks identify it and say, either I need to change a QoS policy or I need to do something different with that traffic or that user behavior. That really gets down to the bottom of solving those congestion issues.
So how would I, as a network engineer, interact with the data that you're gathering? I assume there's probably some kind of GUI and dashboards. Are there other ways for me to like run queries or do searches or drill down into more information?
Yeah, sure. I mean, often our users will start from a knock point of view, and we work with them to build policies that explain, is my network healthy or not healthy, right? Like I don't want to be chasing things that are all green, right? So a lot of our users will set up some dynamic alert policies. We baseline the performance of the network for every single indicator we collect. Doesn't matter what it is, automatically baselined, and that's like a seasonality thing. So if Monday at 10 a.m. is a really busy time in your environment, we start to pick up those trends, and we can say, hey, like we knew that was a busy time. We're not going to send you an alert because that was normal usage. But if we're seeing those high spikes at a time where we don't normally see them, that could drive an alert, that could drive an investigation by the knock, and they might pass that ticket off with a little bit of exploration in the product to say, we've built a report in Sev1 that explains there was a congestion issue at the site. It affected application performance. These different applications is what the users complained about. And the root cause was, hey, there was some traffic maybe shouldn't have been prioritized and was, or traffic vice versa, right? And all that stuff would show up in our flow analysis.
Now, those actions that you were describing mostly were related to alerting and so on. Are there other actions that could be taken? Like, I want to kick off an automation workflow. I want to trigger another tool. These kind of things.
Yeah, sure. Within the Sev1 space, the easiest way to do that is a webhook. And so if you have an alert policy, like, yeah, sure, we can set up an email or something, but the webhooks can really, it's almost like a choose your own adventure, right? Like you can come into a low code product. We have one called Concert Workflows. You've probably seen plenty of things like IFTTT and there's
Oh, yeah.
Node-RED and like there's so many cool things you could do with once I have the trigger coming out of Sev1's detected something. There's really no limit to what you could do with automation.
Is there an API into Sev1 so I can pull data out of it?
Yeah, there's two ways to get data out of it. You can use the API to integrate with other systems, and maybe even your automation needs to come back for more information, but we can also push data to you. So we support Kafka, Apache Kafka or Apache Pulsar as a message bus and just say, as we collect data, you might have a larger strategy around data lakes and data analytics that is bringing in multiple sources of data. I want the network data and the application data and maybe customer support data all coming together for part of a larger data lake strategy. And so we support pushing in real time to those types of systems.
You just reinforced your ability to scale. Like you mentioned near the top of the podcast, how large you can go, the kind of environment you support. Then you dropped Apache Kafka, and I was like, oh, right, this solution goes really big.
It goes really big. Some of our telecom users are just really pushing in the millions of different objects detected and billions of data points a day and petabytes of stuff on the disk. It's pretty significant, the size of these clusters.
What about cloud visibility? Because public cloud and SaaS applications are now part of that application stack. Can you get me visibility there?
We can, and we joked about, hey, like VMware happened yesterday, but we're really mature there. Like we're all in on VMs, but we're really kind of coming to a place of maturity, I think, on the adoption of cloud and putting more of our kind of primary workloads on cloud now. Even if you're like one of the kind of like more blue chip, type of enterprises, and
we meaning the industry is
we meaning the industry, right? Like we work with a lot of large financial companies who would be more slower to move for like good reasons. Is like a lot of our financial transactions still run on mainframes, right? IBM loves the mainframe, but like it's not just a punchline, right? Like it's really powering a lot of these banking and these like stock transactional things. And those folks were probably some of the last to say, yeah, I'd put a primary workload on a public cloud versus my own cloud, my own mainframe, my own data center, right? But as we're doing that and we're seeing that start to become, it's reaching this mature place now. And there's a lot of options on how to interconnect clouds to your own data center and interconnect different clouds to each other, right? So in the Amazon world, right, like each slice of an application you develop might be in its own VPC. How do they talk to each other? You need a VPC gateway, essentially a router in the cloud. You don't manage it, but Sev1 can get those observability metrics and those observability flows from Amazon's APIs. And our team has done some really interesting stuff to help you do that with performance and cost are kind of trade-offs there. If you call the CloudWatch API, they're charging you like pennies per transaction, like everything's metered in Amazon. And we found ways to do that, again, back to our need to achieve this huge amount of scalability. The way that that's working architecturally is Amazon publishes all the data to an S3 bucket. We get a notification, we can pick it up. And the reason why that's important for customers who might be on the large side is they don't have to do all those kind of individual API calls to get all the metrics out. They're coming in bulk, and that's both more cost efficient and kind of it's just more efficient all around. They're getting the metrics they need without all the back and forth.
So there's metrics being generated by like a transit gateway. Amazon is putting them in an S3 bucket as part of its regular dealings, and then Sev1 can make API calls to that S3 bucket as opposed to the transit gateway to save cost.
We wouldn't ever talk to the transit gateway directly.
Okay.
And they're almost like Amazon's almost like magical. Like maybe there isn't even a transit gateway. It's like it might be like 1,000 servers doing that stuff. We don't really know how it works.
Right.
But it exposes metrics through an API they call CloudWatch, right? And that would be both time expensive and money expensive to continually pull that stuff. So we've come up with a solution with Amazon where they push the metrics to us and we can pull them all your transit gateways, all your EC2 instances, all your S3 buckets. Where we're a little bit different from Datadog's an awesome product, right? Like they would say, yeah, we also have cloud visibility. We've really focused on the networking side of it. Of course, we can observe a S3 bucket or an EC2 instance, but when it's like direct connections from data centers to the cloud, when it's NAC gateways and VPC gateways and load balancers, those are the things we think our users and your listeners are kind of the most responsible for and the most interested in. So we focused on being really deep on those technologies, and that's a piece of observability that other classic npm tools might be lacking, but the Datadogs and the APM people may also not be the same level of depth in. So that's the space we decided to focus our energies.
Brandon, I'm at KubeCon this week, and so Kubernetes is kind of top of mind for me. Do you guys do anything special with Kubernetes environments?
We do something I think is really special with Kubernetes environments, and it uses a eBPF sensor that came out of Red Hat as an open source project. It's now part of OpenShift, but anybody running Kubernetes can run this same code. It's called NetObserve, right? And where that ties into network observability and Sev1 is, think about that virtual overlay network in Kubernetes. If you're a senior network engineer and you've been doing this for a long time, you're probably used to opening up a packet capture and kind of understanding what you're seeing across your network. Now there's like packets inside of packets, man, like everything shoved inside of VXLAN. And we don't really know who's talking to who. It's just a bunch of traffic going between Kubernetes nodes. And in order to decode that, you'd have to get really deep into strip off the VXLAN layer but then you have an IP address, right? That IP address is coming from like almost like a DHCP server. I don't know if it is technically, but these are dynamic IP addresses on pods that might be coming and going and getting rescheduled to different nodes as your OpenShift cluster is your Kubernetes cluster is doing its thing, right? What makes this solution really amazing is we're creating these flow records, think NetFlow, right? That tag everything at the source, right? So we're observing it using BPF as the technology of seeing those conversations, intercepting those conversations. You don't need any packet capture devices. You don't need taps and spans and all that type of junk. You just deploy this one operator. It makes sure that this agent runs on every node, and it's rolling up all the conversations in your cluster. But they're already kind of spelled out for you. Back to this idea, we automatically identify all the SaaS applications that are going out to your internet. Same thing in the Kubernetes space, the pod namespace, the destination, who's talking to who, how much are they talking, and then what I think is the coolest field here that we were able to get is measuring round trip times. So it's like, hey, on a per pod to pod basis, round trip times are in the flows. You know exactly who's talking to who, but how long did it take is measured as, we're in the OSI model right now, guys. This is for the real hardcore network engineer. But the time between a SYN and an ACK, when I'm setting up my handshake, we can take that delta, we can store that and say, all right, this is the network time. And what we're doing with that now, Ethan, is pairing that with what Instana knows and what APM products know is say, hey, what's the difference between the network transaction time and like that layer 7 transaction time? Back to the beginning of this conversation, is it the app or is it the network? I really want to know. I really want to solve the real problem here. And that's kind of our next piece of work, is to automatically line up those two pieces of data coming out of one Kubernetes environment.
Yeah, my brain is just like, yes, because the magic here is you can tell me then with that information, especially with what's coming from Instana and being added to the mix, It's a worker node that's got a CPU must be overloaded, or it's having some kind of a hardware problem or something. You can begin to get into the nuts and bolts of what's happening in the cluster and infer what's actually going on down there. Or it's just a pod. It's just a container running on the node that's got an issue because everybody else is having it. But this one is broken for some reason. You can actually surface all of that information.
You totally can. And it's really interesting to me to watch all the things that happen in a Kubernetes cluster that I didn't know were happening. Like it's talking to the core DNS service, and it's talking to this guy called the operator lifecycle manager. And I'm like, I didn't even know all this stuff was happening, man. But when you really need to understand why something's driving the CPU wild, you're like, well, who's consuming it? Right? It's no longer necessarily end users coming in the front door. It might be pods talking to other pods. It's all microservice oriented. And I don't necessarily know where this traffic's coming from until I can really kind of get inside and look into the Kubernetes view of the world.
Are you able to tie IP addresses or flows to specific applications or pieces of applications in a microservice environment to actually help folks track down where the problem is? I'm thinking because this is such an ephemeral environment, that kind of information could be hard to get.
Yeah, so the different fields there, we do record the IP as the source and the destination IP like any other NetFlow collector, but it's already being tagged with the namespace and the pod name. So you could say, hey, I want to see MySQL. Like we have some really powerful filters that we could do queries on top of this stuff and say, hey, show me all the pods talking to MySQL. Show me all the namespaces that come into this namespace. Talk to this guy's MySQL server, this guy's Postgres server. So it's really powerful once you have all those tags there.
Well, Brandon, we've crammed a 15-minute conversation into about 2025, so we got to call this at this point. But man, we got to get you back and have a longer conversation, because the more you talk about different capabilities and use cases, the more intriguing Sev1 is becoming for me. So hey, for folks that have listened to this and maybe they're intrigued as well, where would you send them to find more information?
Yeah, well, actually, I'm probably going to get in trouble for this website, but is snmpdeadyet.com. We'll take you directly there, but
there'll be a link in the show notes to find Sev1. Of course, Sev1, Sevone. You can just do a search for that, IBM Sev1, and of course that's we all know how search works. We're really good at it in 2025, and you can find a whole lot of different resources about that. And of course, is SNMP dead yet? Is another great site. Now, sponsors ensure that the packet pushers can continue to offer high quality, deeply technical content for your professional development. And guys, we give it all to you guys for free. That includes a dozen technical podcasts for your professional development on networking, security, IPv6, DevOps, and more. We have an industry blog. We got 2 weekly newsletters. There's a community Slack group. There's a YouTube channel. There's an IRC group. Yeah, that is still kicking around. That's still a thing. You can find all of those resources at packetpushers.net. And again, it is all free for you, no login required. And you can hear us on Spotify. You can thought lead with us on LinkedIn. Drew and I like doing the thought leadership thing. And then you can rate us on Apple Podcasts. Last but not least, remember that too much networking would never be enough.